Good morning. If you're watching this, it is because you've basically mastered solving equations. And as you know, I really don't want anybody to be doing busy work, so I thought I would push you guys ahead to do inequalities. I tried to write notes on the worksheets, but I was afraid that seeing it written would be kind of confusing and wouldn't make a lot of sense. So I decided to do this little video. I haven't done very many of these and the handwriting's a little bad, but you'll just have to kind of bear with me. So if we're talking about inequalities, and let me just type that up there because it's a whole lot easier than writing. Inequalities. Can't even spell. There we go. Inequalities. So inequalities are stuff like x is less than 3. Could be stuff like x is greater than 4. Maybe x is, I don't think I can do less than or equal to. Nope. Let's do it this way. X is less than or equal to 3. Maybe x is greater than or equal to 2.5. And so the first thing I want to talk about is what does x actually does that mean? So if we look at the first one, x is less than 3. So if you think about some numbers that would make that statement true, I would say 2 is less than 3. 1 is less than 3. -1 is less than 3. Basically, anything to the left of 3 on the number line are smaller numbers than 3. Now, I put that little open circle there because 3 is not less than 3. So if x is 3, that circle is not part of the solution. That's why it's got a little open circle there. It's kind of like a hole. So any number 2.999 would be true, but not 3 itself. If we looked at x is less than or equal to 3. The less than or equal now says that, yeah, x can be 2 or 1 or 0 or -3, but it can also be +3. 3 is less than or equal to 3, so it'd be all the numbers that are to the left and including 3. So we have a solid dot, or sometimes there's no dot at all. Sometimes it just looks like a line. So any number to the left of 3 would be part of the solution. Now, some of you may have heard that the way that the arrow is pointing in the inequality is the same way that you draw the arrow. That is not always true. If I had 3 is less than x, if you kind of look at that the other way, the x is on the bigger side of the arrow. So x is bigger than 3. So when you draw that, you would actually be drawing, there's my 0, and there's my 3. I would need all the numbers to the right of 3. So you can't always just draw the arrow the way that it points in the inequality. You have to really kind of think about it. Okay, so I want to talk about some compound ones. If you kind of get that far, you might be doing some compound ones. Depends on how quickly you caught on to the rest of it and how much of that is review. So if we have and inequalities, so x is greater than 3 and x is less than 7. If you have an and, the and means that both parts must be true at the same time. Both parts must be true at the same time. So instead of just having x is less than, the way we could draw this, if I draw my little number line, I need x to be, there's my 0, there's my 3, there's my 7. X has to be bigger than 3, and it has to be less than 7. So the places where both of those are true are the points between 3 and 7. They both have to be true. If I have an or, let's pick a new color, let's do blue. If I have an or, x is less than 3 or x is greater than 7, this means that only the answer is if either one of these is true. They don't have to be true. They don't have to both be true. So if x is less than 3, it's true. So all the points along this line are true. And, or if x is greater than 7, all of these points over here also make the inequality true. So it doesn't they don't have to be true at the same time, because if it's an or, if I say, do you have brown hair or are you a boy? You're going to say yes if you have brown hair, and you're going to say yes if you're a boy. So both of those parts are part of the solution. If it's an and, they have to be true at the same time. If it's an or, it's one of each. Okay, so if we talk about how we solve, oops, went the wrong way. If we talk about how we solve inequalities, so if I have an inequality, this is probably going to be on day 2. You probably won't see this today. You can always come back and re-look at this video. 2x is less than 3x plus 6. If you're going to solve an inequality, you're going to solve it just like you solve an equation. So I'm going to draw my little squiggly line. I'm going to get all my x's on one side. Whoops, that's kind of an ugly 3, sorry. All my x's on one side, so I get negative x is less than, my 3x's will cancel, is less than 6. And then I need to divide both sides by a negative 1. So you may remember that when you multiply or divide by a negative 1, or a negative number, let me make that a little bit smaller font. When you multiply or divide by a negative number, you must switch the sign. Now, it doesn't matter if the number is negative to start with. It's only dividing by a negative or multiplying by a negative. So if I had x was 2x is less than negative 6. If I want to solve for x, I need to divide both sides by 2. So x is less than negative 3. I didn't have to switch the sign because I didn't divide by a negative number. I divided by a positive 2. So it's only when you multiply or divide by a negative that you have to switch the sign. Otherwise, solving inequalities is the same as solving equations. Now, the last thing is, well, why do you have to switch the signs? So we've talked about the fact that you can multiply both sides of an equation by a number, right? So say I just have this inequality 2 less than 3. Now that's a true statement, right? We'd all agree that 2 is less than 3. If I multiply both sides by negative 1, I get a negative 2 on this side and a negative 3 on that side. So if you think about it, think about which number is smaller. Is the negative 3 smaller or is the negative 2 smaller? If you think about it in a number line, the negative 3 is farther to the left, so the negative 3 is smaller. So when you multiply by a negative, you're essentially flipping to the other side of the number line, and that causes you to need to flip that sign. Same thing with division. If I had 4 is less than 6, and I divide both sides by negative 2. 4 divided by negative 2 is negative 2. 6 divided by negative 2 is negative 3. The smaller number is negative 3. So the bigger part of the arrow needs to be to the bigger part of the arrow needs to be to the bigger number. The smaller part of the arrow needs to be to the smaller number. So I hope this helps. Try not to get too frustrated. I'm not sure how much of this is review, but I really didn't want you to have to solve more equations that you've kind of already figured out. So this is your challenge for the next couple days. So hope everything goes well, and I will see you when I get back. Bye.